here we want to sketch the graph. So I'll try and sketch the graph here. It's kind of a little difficult without the grid marks. But looking at your first graph, you have x minus 3 squared plus 4. Where is the vertex located for this graph? 3, 4. Good. We went right 3, up 4. And then remember to kind of get your next points, you can create an input-output table or know that your next 2 points should be like right 1, left 1, and then up 1. So not the best, but just to kind of get a general sense of what the graphs will look like. And then looking at our next graph, where's the vertex located there?
1, 8.
1, 8. And then what else do we need to know about that graph? Yeah, it reflects down, so it'll look something like this, right? So, what does it mean to be a solution when I'm looking at a graph? How do I know if I have solutions looking at the graph? Good, it's where they intersect, it's where the two graphs cross. So this was a good question in last class. What's the difference between, so actually let me just say, so when you have two functions like we have here, when you have two with a system, so when you have two graphs, the word solutions talks about where your two graphs do what? Where they intersect. If you just had one function, so if I just had this second graph here, that one function, and if I say the word solutions, what is that word talking about? The x-intercepts. Good. So note that if you just have one graph or one function, the word solutions talks about your x-intercepts. But when you have two, it's talking about where the two graphs do what? Intersect. Good. So where the two graphs or functions intersect. What does it mean algebraically to be solutions here? So when they are intersecting, they intersect at a point. So think about what does like that point mean within that equation. What do you think, Arthur? Yeah, it's what x and y equal. So think about your x value is your input. So it's the inputs that would produce the same what? Outputs, right? So if you input like 5 into both of these graphs, if it is a solution, they would have the same output. So your inputs have the same output. So how many solutions does this system have? 2, because it intersected how many times? Twice. Good. So let's solve this algebraically using substitution. So what we went over last time. So I'm just going to rewrite it over here. Can I read your screen? So we have y equals x minus 3 squared plus 4. So if we're using substitution here, what could we do first? Good, set them equal to each other. So the part of this whole process that you guys are struggling with the most is just the basic Algebra 1 content. So thinking about you're setting both of them equal to each other, right? So talking about this first one here on the left, when I want to simplify it, because thinking about for me to keep solving from here, I'm going to need to expand this and then simplify it. So think about your basics, your order of operations, right? First, you should be doing your exponents, which means I should be squaring that x minus 3 squared. So expand that out into that trinomial, and then you should be adding 4. So when you do that, what did that simplify to? So it should be like x squared, and then it was? Plus 13? Because this was plus 9 and then plus 4 to give you plus 13. So then over here on the right side, think about your order of operations, parentheses, exponents. So that means I needed to square this out first. And then after I do exponents, it's multiplication. So I have to multiply that full trinomial by what? That -1. And then after that, we have to add 8. So after we did that, we would get, what was it, negative x squared, and then it was it plus 2x? And then it was plus 7. So that should be what after you simplified. So once you're here, think about we were kind of here before. What do we want it to be equal to? 0. So we will add x squared, subtract 2x, and subtract 7. So we end up getting 2x squared minus 8x plus 6 equals 0. So now you're thinking to yourself, can you factor? What do you think? Can we factor? Probably. And when I'm factoring, I want to ask what question first? GCF. So do I have a GCF here? What's the GCF? 2. So think about factoring out at 2. We would have x squared minus 4x plus 3 equals 0. And then we want to keep factoring, so what are our factors end up being? X minus 1 and x minus 3. So you factored, now you set each factor equal to 0 and solve. So you know one solution is x equaling 1, another one is x equaling 3, but is that where you're done? No. What do you do with those x values? Good, you plug it in, and then what did you find the y values that go with it to be? 1, you get a y value of what? 8. 3, we get a y value of 4. Remember, you're writing them as ordered pairs. So a couple of questions that have come up about when you have a GCF, your 2, that GCF out here. Does that 2 have a variable with it?
No.
No, so then you can kind of ignore it, right? So if you didn't factor out your GCF, you might have one factor like 2x minus 2 equaling 0. If you were to solve that, you would still get x equaling 1. So that's kind of like that 2 up there. When you factor it out, it just makes it so your equations are more like one-step equations than two-step equations. So if you had a 2 with an x as your GCF out here, like we did on our test, but a lot of us kind of missed. So if I had something like 2x and then x minus 1, when that 2 has an x with it as a GCF out here, that's when you really have to pay attention to it because it has a variable. That means that is one of your factors. So one of your factors is 2x equaling 0, which just means x is what? 0. And then your other one is x minus 1 equaling 0, so you know x is just equal to 1. So that would be that kind of scenario, which is different. So just keep that in mind. You might see that on like a few problems later today too. All right, so do we want to go over using the calculator one more time again? Okay, so let's check those solutions. with our calculator. So if you're following along, where should I go first? Y equals good. So I'm going to y equals, and I'm entering both those equations. So take like 10 seconds or 15 seconds to do both of those. Sure. It's on the battery, huh? Alright, so you have both of those equations entered. So where do you go from here to find the solutions?
Second trace.
Second trace, good. So second trace. Yep, option number 5, so I want the intersection. And then from there, you just hit enter 1, 2, 3 times. So I found one intersection point was 3, 4. Maybe when you hit enter 3 times, you found that 1, 8. It doesn't matter which one you found first. Just note that you have to do the process again to find the other one. So second time around, still doing second trace. 5 for intersect. But now to get the second one, I gotta kind of wiggle that cursor over to like where the other intersection is. So then from there, I'll hit my enter 1, 2, 3 times, and I get 1, 8. So where are our solutions, right? Yeah, good. All right, so looking at our next couple of questions. So these were just kind of a variety of answers could have worked. You could have just created new ones. So let's think about if you have 2 quadratics, so 2 of those U-shaped graphs. Can you ever have 3 solutions? No, what's the maximum number you could have? 2, so this is not possible. So can I have 2 solutions?
Yes.
Right, did I have 2 solutions in that previous problem?
Yes.
So do I need to change those graphs at all?
No.
Nope, so keep the same for those graphs. So if I only have 1 solution, what does that mean? What would that look like graphically? Okay, but I'd have quadratics, so I have those U's now. So 1 U, but I have a system, so I have to have 2. But I have 1 solution, so that means what would it look like graphically? So Luke is showing something that looks like this, where your U's look like this. So see how that would only intersect right here, right? That only intersects 1 time. What's another way you could make it look like graphically? Yeah, like your vertexes, right? So if just your vertexes touch that 1 time. So any creation that you created with those graphs, just check it in your calculator. Just make sure they intersect that 1 time. What would it look like for there to be no solutions? They're not beside each other. Oh, okay, so Gabe just brought up a good point. So if you have, so if I have no solution, so what if it's something like these 2 U's? Will they ever intersect? Yes. Remember, your domain keeps going for here to positive infinity. This domain over here is going to keep going to negative infinity. At some point, they're going to intersect. So what would it have to look like to be no solution? Yeah, 1 should be up and 1 should be down. So that way they're never crossing. So how are we feeling? I think we're doing okay with substitution. Everyone's understanding the process. So the process when you have two quadratics is still the same as when you just had one in a linear. So we're going to do a couple elimination problems together, and then you guys will spend the rest of the time just working on the rest of that packet on your own. So if you could go to the very last page. So remember back to your linear functions, the process is still going to be the same, just a little bit more to it. When you were eliminating, what was your goal with elimination? To take out one of the variables, right? So like it cross one of those variables out. So that way we only had x's or we only had y's. So that's our same goal here. We only want to have x's or we only want to have our y terms. So, and remember when we did that, we kind of would line up our x's, line up our y's, and it would be equal to the number. So same thing here. So let's rewrite this one first. So when you're eliminating, think about that idea of eliminating a variable. That means one of them is equaling what if they're eliminated? 0. Good. So rewriting, so we have our x squared, then our y squareds, then our numbers. So let's think right now, can our x's be eliminated? Would they equal 0? No. Would our y's equal 0? No, so we have to do something to make them equal to 0. Does anybody have any ideas? Multiply one of the equations by -1. That would eliminate what variable? Y. So let's multiply our second equation by -1. So we have 9x squared minus y squared equals -16. So think about adding these together. 5x squared plus 9x squared would give us how many? Good. 14x squared. Those y's we know became 0. It equals 14. So we've been here before. We've solved for an x squared. So what are we doing? Good. Dividing both sides by 14. So I have x squared is equal to 1. So what is x equal to? Plus or minus. Our number one mistake, everybody. Plus or minus 1. It's not going away. Remember, every time I'm solving by taking that square root, I have to add that plus or minus. So x can be plus or minus 1. So if I have my x as positive or -1, what do I need to find next? The y. So the process is still the same. I'm plugging in my x to find my y. So just plugging it back into one of your original equations. So let's just pick the first one. So if I have 5, 1 squared plus y squared equals 30. So 5 times 1 squared would just give us 5. If I subtract 5 on both sides, we just have y squared is equal to 25. Good, so y is equal to plus or minus 5. So here's the part where it gets a little tricky. What was my input that I just put in for x? 1. What was one of my outputs? It was a positive 5, right? And then also when I input 1, my output was also -5. So when my input was just that positive 1, I had 2 outputs right there. But I don't just have 1 as the input, I also have to think about it with -1, 2. So inputting now for -1, so same thing's going to happen, right? 5 times -1 squared would still become 5. Subtract 5 on both sides, so I would have y squared is equal to 25, so I know y is equal to plus or minus 5. So when my input, my x value was -1, one of my outputs, one of my y values was 5, and my other output was -5. So I have how many solutions here? 4. But we just said a quadratic and a quadratic should have a max of how many? 2. So were both of these quadratics? No. So these were both ellipses, which if you remember, they're both like ovals. So think about those two ovals are like intersecting each other 4 times. Yes. Yeah. All right. So thinking about that's why we have 4 solutions here, because that oval and that oval are on top of each other. So like graphically, something like this. So you have 1, 2, 3, 4 solutions. That's what it kind of looks like graphically. But you don't need to worry about the graphing part of it. Just think about the algebraic part of eliminating one of those variables and then plugging it back in to find the other one. Do you guys have any questions about the process so far? All right, so let's check out number 6. So are we set up for elimination already? Yeah, what variable will eliminate? Y. I have a negative, positive y. So we would just have 4x squared plus x minus 5 squared equals 100. Here we go. So simplifying from here, remember we're going to have to expand out that x minus 5. Write it out 2 times to FOIL it through, or remember you can still use that square, double square trick. So if you square your first term, double the 2, so you have 10x minus 10x, and then square your last term for 25. And then same process from here. What do we want it to be equal to? To 0, right? So I'm going to have to subtract 100, and what do I have to do with these guys here? Yep, combine your like terms. So you'd have 5x squared minus 10x minus 75 equals 0. What should we ask ourselves right now? Yeah, factoring. So then my first question with factoring is, do I have a GCF? What's our GCF here? 5. So we have x squared minus 2x minus 15. And then I want to think about what are the factors. So what are our factors? Good. X minus 5 and x plus 3. So then you set each factor equal to 0, and we know x should equal what and what?
1 and -3.
Good. So if I have my x's, what should I do next to find the y's? Yep, substitute, plug it back in. I'm just going to plug it into the second equation because it looks a little easier for me. So we'll have 5 minus 5 squared plus y squared equals 64. So what's 5 minus 5 going to become? 0. 0 squared would just be 0. So I just have y squared is equal to 64. So y is equal to what? Good. Plus or minus 8. So I know when my x is 5, I have positive 8 and negative 8 too. So far I have 2 solutions. Let's see how many more we will have. So next we're inputting -3. So I have -3 minus 5 squared plus y squared equals 64. So what's -3 minus 5 become? -8. -8 squared would be 64. So if we subtract 64 on both sides, what would it become? Good. So I have y squared is equal to 0, which just means y is.
Zero.
So my other solution was -3, 0. So thinking about, do you guys remember? So this first one is like a hyperbola, which looks like kind of two parabolas on its side. What's your second one? Do you remember it from geometry? Not a triangle. What is that? What's that an equation of? Parallel lines. Those are two. Oh, parallelogram? No. It's a circle. Yeah, remember? They're like centers at 5, 0. Your radius is 8. That's a circle. So think about, you have something that looks like this. You have a circle, then you have something like this to get your 3 solutions. So you have like something hitting here, and then these 2 right here. So no, so kind of the connection is, you should just really be focused on the algebra part, the graphing and knowing all the different types. They took it out of the curriculum this year, so you used to have to know it. But we are not focusing on that this year, just focusing on the algebraic part. So you guys try 7 and 8 on your own, and I can check it for you when you're done. And then when you're done with 7 and 8, flip back to the page before and work on that page.